Okay, hi everyone. Hope you're enjoying this year the WWDC and AltConf experience. And today I'm gonna say you something about core data performance and how we can build our core data stack to be more effective in some steps. So let's dive in. First of all, you could say, yeah, core data, we know it, we like it, or hate it as well. And finally, and first of all, you would probably ask, seriously, we are using it today, who do that? So, well, I do, because, see, there are projects where it is the best approach to use the native solutions instead of, for example, adding some third-party solutions and so. And sometimes you just can't add something which is outside some third-party solutions. And just trust me, I'm work for the enterprise, and this is set through. So core data. So why the core data is so hated and why we don't like it? Well, 3 points here. First, I think it's misunderstood. Like in core data, there are lots of things we should remember to avoid a problem with efficiency, concurrency, etc. We should think that we should think what we ask for it. This is very important, and it might provoke some problems. It's difficult to set up. It's quite difficult. Of course, with next versions of this Xcode, it becomes way better. But still, it's quite challenging, especially for new developers, to properly set up. And the last one, in my opinion, is threading, which is a nightmare, especially, as I mentioned, for newbies, but not only, as we know. But hey, there must be a good point that core data is a good solution. And I think they are. First of all, the data model in Xcode. So we can easily manage our data model in Xcode. It gives us a bunch of tools and allows us to manage our model with both visual and code ways. So I think that's cool. Secondly, it's extremely fast. And I know you could say there are lots of solutions which are way, way faster, like Realm, for example. But to be honest, I think the core data is, in most cases, his speed is more than enough. So I think it's really fast if you know how to achieve it. And also, it's a native solutions. And in a native solution, I prefer personally to use native solutions sometimes because I'm strongly convinced that the platform vendor will support me and my project and my app with this solution. So it doesn't mean I don't like third party, of course, but an open source project. But sometimes it's better to use the native solution. I want to focus on 3 points about which, in my opinion, are the most expensive about the performance and are just increasing this in core data. So we should be careful how we manage our fetching and deleting process and objects. We have to do threading when necessary. So we need to move our huge jobs to the background to let main thread works smoothly. And as I mentioned before, we should be very careful what we ask for. I will show that on an example, how to slow and lock your screens, in example, when you block the main thread. All right, the tech itself. So core data, this is the stack of core data. On the top, we have our manage object context, which is responsible, for example, for managing our data changes. Then there is persistent container, which contains manage object models. Next, we have persistent store object and store file itself. We know it very well. This is the model core data stack we want to use because this is all implemented in core data framework yet, but not so much user-friendly. We need to write our own stack to just easily use it in our projects. So first things first. We are creating a final class for core data stack like this. So we have a private parameter, which is the model name, and then we initialize it in a constructor. Then the manage object context, it's like a standard code we are creating when we manage our core data stack. So we create a manage context. In that case, we are using just one manage context. And if we are here, we can also create the save context method to save our data changes if there are some. This is really important not to save the data when there is no changes. Then the persistent container, like this, for this approach, it's initialized with a model name we pass through the class constructor. This is a standard code for our core data stack. So now is the thing. The method to get and set, to get and one object and the set of objects. Look that we have two methods, which depends on how many objects we want to fetch. Because why we should fetch all objects and then searching the one we want. We just easily set the fetch limit and set the predicate. And this is a good thing. This is about the example of the get a single object. So it's way faster and implemented in core data itself. Thanks to this, we would get just one object fitting the criteria, of course, if there is some. The second thing, this is more interesting. The first example is using the same method to fetch just one entity, but look at this second method. It's like fetching all the objects from the core data and then iterating every single object. And if you do that, you can end up with a main thread blocked, especially when there are lots of objects. It can finish with something like the user doesn't want to see something like this. And you block your main thread, and you have a problem. And your user also thinks that this is a problem. So, well, core data gives us the opportunity to create a batch delete request to delete all objects as one. But there are some steps we should remember, and this is the tricky part. So first, execute method, it's a returnable function. We could get the batch delete result in a response, so I will do that. Like, this is the batch result. And I will let the result here and store it in a parameter. Then, we use the result to manage and store the changes in a dictionary. And then, we do need to merge the changes. Batch delete is an asynchronous action, and we need to remember that core data context is saving always on the main thread, so to avoid the trading data, we need to do something like this. Now we have a good example of batch delete to whole entity with objects. So as I mentioned before, 3 main points, 3 points just in this one example were shown. So carry your get delete objects logic, your threading, and watch out what you want to achieve. Last but not least of my lightning talk, I just want to show you the better stack you can implement in your app. So first of all, not all applications should work just with one context. On the other hand, we potentially can have lots of objects in just one entity, which will be extremely expensive for the performance of the app. So we need the pattern which allows us to support more than one. And that we can easily implement the persistent coordinator, which contains private manage context, which in the other hands contain our main manage context. In that case, we can easily avoid to block the main thread because we are not pushing to the persistent store directly, but with support of persistent coordinator. He's responsible for that action. And the obligation of coordinator is in that case to manage all changes and then push them directly to persistent store. And there might be easily more managed context in our app. So if someone is interested about the implementation, I will go around and we can talk about how to implement this solution. Yeah, so the persistent coordinator is the most important. And that's all for the lightning talk. Thank you for your attention. Thank you for having me today. And have a great weekend.